Hi, we're going to deal with special triangles this time, and that's a 30, 60, 90 degree triangle and a 45, 45, 90 degree triangle. The reason that we use them is that they're very common in trigonometry and they give you exact values, and exact values are preferred to the decimal values, which are estimates. So do you need them for NCEA level 3? The answer is no. It just makes your answer more elegant. The 45-45 degree triangle, if you imagine a 45 degree right angle triangle, then it means that that side there must be equal to that side there. In other words, it must be an isosceles triangle. For convenience, we're going to make that side 1 unit and that side 1 unit. They will be the same. Okay, if that side is 1, that side is 1. By Pythagoras, 1 squared plus 1 squared gives you 1 plus 1, which is 2. And so this side will be the square root of 2 by Pythagoras' theorem. What that means is that if you want to work out the sine of 45 degrees, let's take this one, would be the opposite over the hypotenuse, which would be 1 over root 2. That is preferable to the decimal value of that, and the decimal value of that is, let me just work it out, is 0.7071. Okay, 7071. Now that value is not a very nice value. It's much nicer to use the exact value. And when they talk about exact values, they mean 1 over root 2, and they just leave it as 1 over root 2. If you want to work out the cosine of 45 degrees, using this 45 degrees here, that would be the adjacent over the hypotenuse, which is still 1 over root 2. The tangent of 45 for following the special triangle, if that would be the opposite, which is 1, over the adjacent, which is 1, which is 1. So these three values here, 1 over root 2, 1 over root 2, and the tan of 45 are exact values, and you can use them instead of writing the decimals. It makes a more elegant answer. So what happens with the 30, 60, 90 degree triangle? Well, if you've got a 60 degree triangle, then this one here must be 60 degrees as well. In other words, that there must be an equilateral triangle. Because we're dealing with right angled triangles, what we're going to do is we're going to divide the triangle in half. Okay, if we do that, then there we get a right angled triangle on the left hand side and the right hand side. And for convenience sake, if I make that 2 units and that 2 units, that will be 1 and that will be 1. And using the 2 and the 1 is convenient in this case here. So that gives us a right angled triangle that looks like this. Very roughly, it's a 2, 1, root 3. It's root 3 because 2 squared by Pythagoras' theorem. If I'm trying to find the right-hand side, there would be 2 squared, which is 4, minus 1 squared, which is 4, minus 1, which is 3, and this side will be root 3. This you will find on your back of your formula sheet. If that's the case there, that one there needs to be 60 degrees, and that one there is 30 degrees because angles in a triangle add up to 180. But the one you actually find in your formula sheet actually does it in radians. So that's root 3, that's 2, that's 1, and a radian, which is 60 degrees, and radian measure is pi over 3, and that one here I'm just going to draw over here is pi over 6. So pi over 3, pi over 6 are the angles that you find in radians in your formula sheet. What does that mean for us? Well, if I do sine of 60, here's 60, we'll do it with this one here, sine of 60 would be the opposite. Remember we said that's root 3. So root 3 over 2. Okay, the cos 60, which is the adjacent. The adjacent is 1. So 1 over the hypotenuse, which is 1 over 2. And the tan of 60 works out to be, tan is the opposite over the adjacent, which is root 3 over 1.